Find the area bounded by r is equal to negative 12 cosine theta and r is equal to 6. Okay, so I've already drawn these graphs, and we're looking for the region that's bounded right here between these two circles. So they're both circles of radius 6. This one's just been shifted over to the left by 6. So this is the area in between. So we need to somehow find this area. So the first thing I need to do is set these things equal to each other. Negative 12 cosine theta is equal to 6. So cosine theta is equal to negative 1/2. Okay, and that will tell me my intersection points. Okay, so where we can see that this is in the third and the fourth, or the the second and the third quadrant. So here and here. Okay, so where do they intersect exactly, or where does cosine theta equal to negative 1/2? Okay, well, you can look at your unit circle to see where cosine theta is equal to negative 1/2, but that is going to happen at theta is equal to 2 pi over 3, and again at 4 pi over 3. So those are your two intersection points right there and right there. Okay, so now that we found our intersection points, we need to split this thing up in a way that allows us to find the area. So one thing I can do, if I'm looking at just the circles r equals 6, I can find this area if I start here, this little arrow or this little line here and here. I can find this area here by taking the integral of this function over between 2 pi over 3 and 4 pi over 3. But that is going to exclude this little sliver here and this little sliver here. So on those two places, we're going to have to use the other function. And we'll start from where the third quadrant starts, right here at pi over 2, to the first one will be to 2 pi over 3. And then the second one will be from where they intersect here at 4 pi over 3 all the way over to 3 pi over 2. Okay, so we're going to set up the integral. And also, to find the area, we're going to use this formula. Okay, so that's the formula we're going to use for these polar equations. Okay, so the first integral I'm going to set up will be to find this little sliver right here. So I'm going to use this function. Okay, and for the first one, I'll label it 1. I'll go from pi over 2, which is up top here, to the intersection point, 2 pi over 3. Okay, and that will be 1/2 times the function negative 12 cosine theta squared d theta. Okay, plus the second one will go from 2 pi over 3 to 4 pi over 3. Okay, that's that area that I shaded there, and that's going to be using r equals 6. It's going to be using this circle. So we're going to find the area of this little swath right here. So we'll go from 2 pi over 3 to 4 pi over 3, and that'll give us that. So that's going to be 1/2 times 6 squared d theta. And then my third integral will be the other little sliver here, which will go from, let's see, 4 pi over 3 to 3 pi over 2. Recall that 3 pi over 2 is down here. So it'll be finding this little area here. Okay, and that will be the same as this one, 1/2 times negative 12 cosine theta squared d theta. Okay, so those are our three integrals that we're going to find, and when we find the answer to those, we will have found the area between these two curves. Okay, so let's start with the first one. Let's clean it up a little bit. So I'll clean it up. Let's see, pi over 2 to 2 pi over 3. Let's see, negative 12 gets squared. That's 144 times 1/2 is 72. So I'll put a 72 here. 72 cosine squared theta, d theta. And let's see, I can leave the 72 out front. And I'm going to use a trig identity here, the half angle formula, to change this into cosine, or 1 plus cosine 2 theta over 2 d theta. And then we can integrate that. You can integrate that in pieces. You could split this up into 1/2 in cosine 2 theta over 2. But that's going to give you 72, that's from here, times theta over 2 plus sine 2 theta over 4. And that's going to be integrated, of course, from pi over 2 to, did I put 2 pi over 2 there? That should have been, what, 2 pi over, or 3 pi, no, let's see, what was that? 2 pi over 3, yeah, there we go. Okay, to 2 pi over 3. Excuse me, little lapse there. Okay, so the nice thing about this is once you take this integral, notice that this is the exact same. So I'm doing it in 3 different parts, but this and this have the same result. We just have to have different limits of integration. Okay. All right. So for the second one, let's see what we got here. 6 squared is 36 times 1/2 is 18. Okay. So I am going to be integrating from 2 pi over 3 to 4 pi over 3. And that's going to be 18 d theta, which of course is 18 theta integrated from our limits. Okay, we'll come back to that. Let's do the third one. Okay, like I said, on the third one, we don't need to do all this work. We've already done it. So we know we got the answer here, which is 72 times theta over 2 plus sine 2 theta over 4. But this time our limits of integration will be from 4 pi over 3 to 3 pi over 2. Okay, so that gives us all of our integrals. Now we need to just pop in our limits of integration here. Okay, so let's see what we got. Let's go back to the first one. So for the first one, looking at this one right here, okay, I'm going to pop in a 2 pi over 3 in place of both of these, and then a pi over 2. So here's my 72. When I put a 2 pi over 3 in place of theta, it's 2 pi over 3 over 2. So that's going to end up being pi over 3. Okay, and then when I put the 2 pi over 3 into sine 2 theta, I get sine 4 pi over 3 over 4. So plus sine of 4 pi over 3 over 4. Okay, and then do the lower integrations, which means I need to subtract. And let's see, pi over 2 goes in here, and it's also divided by 2, so that'll be pi over 4, so minus pi over 4. I'm subtracting because I'm plugging in my lower integration here, so you always subtract. I could put a parentheses, but instead I'm just going to put a minus on both of these parts here. Okay, so I'll also put a minus in front of here. And let's see, 2 theta, we plug in a pi over 2, that's just sine of pi over 4. Okay, so let's see, pi over 3 minus pi over 4 gives us pi over 12. Okay, and then let's see, the sine of 4 pi over 3, that's going to be negative root 3 over 2, which means it's going to be negative root 3 over 8 because we've got this. So minus root 3 over, let's see, minus root 3 over 8. Okay, and then sine of pi is 0, so that one's going to go away. So that takes care of the first one. If you want to clean it up one step further, you can distribute the 72. Let's see, that goes in 6 times with the 12, so that becomes 6 pi. And then this becomes minus, let's see, that's 9 root 3. Okay, so there's the first one. Okay, the second one should be a little easier because we're just popping into 18 times both of these. Okay, so it would be 18 times 4 pi over 3 minus 2 pi over 3, which gives you 18 times 2 pi over 3. Let's see, which would give you 12 pi. Okay, so there's the second one. All right, and now for the third one. Okay, so the third one we get 72 times, let's see, plug in the upper limit of 3 pi over 2 here, and that becomes 3 pi over 4. Okay, and then plug in the upper limit here, 3 pi over 2 here, the 2's cancel, and you're just left with 3 pi. So minus sine of 3 pi, don't forget the denominator of 4. Okay, minus, let's see, let's plug in the lower limit. So 4 pi over 3, that's going to be 4 pi over 6, or 2 pi over 3. So minus 2 pi over 3. And then minus, let's see, sine of 8 pi over 3, if we plug that in, over 4. Okay. Let's see, so 3 pi over 4 minus 2 pi over 3 is also going to be pi over 12. So this is equal to 72 times pi over 12. Okay, and then this one, sine of 3 pi is going to turn into, let's see, that's going to turn into 0. Okay, and then this one, 8 pi over 3 is going to turn into root 3 over 3. Remember, this is the same thing as 2 pi over 3. So that's, remember the negative, so negative root 3 over 2, but it's also over 4, so over 8. Okay, so it's actually going to give you the exact same answer as the first one did. Okay, so likewise, it's going to reduce to 6 pi minus 9 roots of 3. Okay, so this one, and this one, if we combine those together, we get our answer. So 6 pi plus 12 pi plus 6 pi is, let's do the total area. This is total area, is going to be 24 pi. That's all, this one, and this one. And then the negative 9 roots of 3 and the negative 9 roots of 3 is negative 18 roots of 3. And that'll do it. That's the answer.